Hello class, welcome to Pre-Algebra Lesson 2-3, which is all about comparing and ordering real numbers. By the end of this lesson, you should be able to compare and order rational and irrational numbers. Just a reminder, we've been talking about rational numbers and irrational numbers these last few days. Rational are all of your, decimals that are repeating or terminating, or they're our fractions. And our irrationals are those decimals that are not repeating and not terminating. Okay, so we are looking at all of the types of numbers that we have worked with so far. We're looking at today. So start with approximating an irrational number, because remember, we're still not using our calculators. We have this problem right here. Darcy wants to add the ribbon shown, so that's this 8.5 kind of reddish pink ribbon shown. So she wants to add that ribbon along the diagonal, which cuts from one corner to the opposite corner of the rectangular flag she is designing. Does Darcy have enough ribbon? Explain. So looking at this problem, we see that the ribbon is 8.5 feet, right? So the ribbon is 8.5 feet. And then we see that the diagonal is the square root of 74 feet. Excuse me. Your brains are probably looking at these two numbers and saying, 8.5, that makes sense. Square root of 74, I have no idea what that is. And at this point, that's kind of what I would expect from you, okay? So if you're feeling that way, you are just fine. Let's talk about how you would figure this out, though. So the whole point of today is that we are going to try to figure out what the square root of 74 is without using a calculator. So this is where I want to remind you of those kind of perfect squares that we talked about, right? We talked about how 1 squared is 1, so the square root of 1, that equals 1. 2 squared is 4, so square root of 4, that's really the same as saying 2. 3 squared is 9, that's the same as saying 3. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. And excuse me, I'm going to stop right there. And the reason I'm going to stop is because I am now reaching numbers that are bigger than the square root we were originally talking about, right? So if I were to draw a number line, I see that the square root of 74, that has to be somewhere between these two numbers, right? Somewhere between the square root of 64, which is known as 8 on our number line, or the square root of 81, which we refer to as 9. Okay, so right here I'm going to put 8.5, and then we could have like 8.1, 8.2, 8.3, 8.4, 8.5, 8.6, 8.7, 8.8, 8.9. Okay, so you can see not a perfectly drawn number line, but it gets the job done. So looking at this, we know that our ribbon is 8.5 feet, right? So that is right here. This is our ribbon. I'm just going to mark it with the R. Okay, now we have to figure out where is that square root of 74. So let's think about this. Is the number 74, is that closer to 64 or is that closer to 81? Well, it's 10 above 64, right? But it's only 7 below 81. So I know this square root of 74 has to be closer to this 81, right? So this is where you're going to do a little bit of trial and error. Okay? So this is where you can say, you can approach it a few different ways. First, you could see, what is 8.5 times 8.5? Is that 74? Is that going to work out perfectly? Let's see. So if I test it out, 8.5 times 8.5. 5 times 5 is 25. I carry the 2. 5 times 8 is 40, plus 2 is 42. I put that 0 down. I'm done with that 2. Now I start again. 8 times 5 is 40, so I put the 0 down, I carry the 4 up. 8 times 8 is 64, plus 4 is 68. So if I were to add those two together, 5 plus 0 is 5, 2 plus 0 is 2, 4 plus 8 is 12, so I carry the 1. 1 plus 6 is 7. I have 2 digits behind the decimal place, so I need 2 digits behind the decimal place. Okay, so I know that 8.5 squared, this is the same as the square root of 72.25, which is still smaller than that square root of 74. So, right now, I could say, you know what? 8.5 feet, that's not going to be enough, because it would only give us 72.25, the square root of 72.25, and that's less than the square root of 74. Another way that you maybe approach this, because maybe you did it a little bit different, maybe instead of doing 8.5 times 8.5, you started doing some guess and check. So maybe you said, I'm going to test like 8.6. So then you would do that. Oops. It'd help if I wrote the same number. So 8.6 times 8.6. And when you did that, you were able to see that you would have 4. Oops, I just wrote my numbers backwards. Let me try that one more time. So 64, that'd be 68. So you could see if you did 8.6 times 8.6, I would have 73.96. That is pretty close to that square root of 74. So she would need at least, if she was cutting it by tenths, she would need at least 8.7 feet in order to cover that entire diagonal. Because if she did 8.6 feet, that's not going to be the entire length either. Okay, so you would be able to say it that way as well. So maybe you did a guess and check method, and that's just fine. Let's take a look at this problem now, where we are just trying to determine where that square root of 12 is, between which two whole numbers. So on this last problem, you can see that the square root of 74, we determined that's between the number 8 and it's between 9. So between 8 and 9. So now I'm asking you, what is the square root of 12 between what two numbers? Go ahead, take a moment, and solve it on your own. Good luck. Alright, for this problem, hopefully you said that the square root of 12 is between the numbers 3 and 4. And the reason it would be that is 3 squared is 9, so the square root of 9 is 3, and the square root of 16 is 4. And 12 is going to be between 9 and 16. If you have questions about that, please be sure to ask for some help. I am happy to help you. Let's try another problem. We have compare the square root of 32 and 5.51326 ... So it's going to keep going. Plot each number at its approximate location, on a number line. Okay, so this 5.51326. Here's 5.5. This is going to be like just off to the side, right? Because it's just a little bit more than that 5.5. That one, usually pretty straightforward for plotting on a number line. But that square root of 32, again, that gets a little trickier. But this number line does tell us it's between 5 and 6, right? So let's figure out. We have 5 squared. 5 times 5 is 25. And 6 squared is 36. So is 32 closer to 25 or 36? It's going to be closer to that 36. So I'm going to actually start closer to the 36 and see what I end up with. So what I mean by that is Here is 6, or the square root of 36. I'm going to try something closer over here. So if I were to try like 5.7 times 5.7, what would I get? So for me, I discovered that my guess was actually pretty close to being accurate. When I did 5.7 times 5.7, I got 32.49. So, excuse me, that's a little bit higher than the number I was looking for. So I know here's my 5.7, right? What I'm going to do is I would go a little bit lower on the number line. And when you are doing this, do you have to be perfect? No, but I should see work. I should see kind of like some of these approximations, and I should see things labeled on your number lines, okay? So it would look something like this for your problem. Hopefully that makes sense. If not, ask questions, okay? But let's try our last problem for today. We are going to compare and order the numbers below, and we are going to do least to greatest, okay? So right off the bat, I see I have pi squared, 9.5, 9.8, 9.5 repeating, and the square root of 94. So I'm going to start right here with that pi squared. So we usually approximate pi to be 3.14. So that's what I'm going to do, is I'm going to do 3.14 times 3.14, and I am going to get 9.8596. Okay, there's my work off to the side, and then I also wrote it above pi squared. Okay, so now I know what this equals as a decimal, which makes it easier to compare and determine what numbers are bigger. Okay, then I have 9.5. What's 1/2 as a decimal? That's just 0.5. So I'd say 9.5. And then I have 9.8. And sometimes with these decimals, I like to just write it off like above with all of the other numbers that I'm converting to decimals. And the reason I do that is sometimes I miss a number if I don't. Like when I go to write my final answer, I will look at everything I wrote above and I will miss the number that I didn't write. So that's why I do that. 9.5 repeating. And then we have to figure out the square root of 94, right? So that's going to be, I just know, 9 squared is 81. So it's going to be between the square root of 81, which is 9, and 100, which is the square root of 100, which is 10. And if I were to do that, I know that 94 is a lot closer to 100, right? So I could test something out. So I could say what's like 9.8 times 9.8, right? So if I do 9.8 times 9.8, I get 96.04. If I were to try like 90 or 9.7 times 9.7, because 96.04 is a little higher than 94, right? So I'm going to try 9.7 times 9.7 and see what I get. So with the 9.7 times the 9.7, I got 94.09. So I know that that's pretty close, right? This is going to be about 9.7. And sometimes when I say about, you're going to see me do these little squiggly like equal sign. That just tells you that I'm rounding, okay? That it's not exactly equal to that. We would actually say approximately equal to, or students will often say about 9.7, and I have picked that up from you guys, and that is just fine. It means the same thing. I just want to make sure you know what that means. Now let's take all of these numbers and let's write them in order from least to greatest. So I have 9.8596, 9.5, 9.8, 9.5 repeating, and about 9.7. So my smallest number is actually going to be that 9.5. And when I write it, instead of writing 9.5, that decimal form, I'm going to convert it back to what it started as. Okay, so I have 9 and 1/2. Alright, then I sometimes like to cross it off just to help make sure I don't miss anything. Alright, so I have 9.5. The next step is going to be that 9.5 repeating. So I'm going to put 9.5 repeating using that bar notation, cross it off. Now I have 9.7, or that about 9.7. That's going to be the square root of 94. I can cross that off. And then I have 9.8, just the regular old 9.8. And then I have that 9.8596, or pi squared. And that is how you would solve this problem to get it from least to greatest. So hopefully that process makes sense. If not, ask questions. I'm here to help. And that's everything. Have a great day.